one thing that is left is grid search and cross validation. These are called as hyperparameter tuning, and this is a very important part of machine learning. The aim of this is to improve the performance of our model. So performance can be the prediction accuracy of our machine learning model. So let us say we have a linear regression model. Previous videos you have seen that y prediction is mx plus c. This is the form of linear regression model. In this model, if you see the implementation of the model in Scikit-learn library, there are certain settings. First setting is the positive and second setting is the intercept. If we decide to set the positive setting as true, it can also be set as false, whereas the intercept setting can also be set as true or false. So if we set positive to true and intercept to true, that means the m, that is the importance, will always be greater than or equal to 0. Whereas if intercept is true, then we will be using this intercept. But if positive is false and intercept is false, then we get a different machine learning model. So this is LR1. We will so I will just write here that LR1, which is the linear regression 1, it will have positive as true and intercept also as true. LR2, which will be having positive as false and intercept as false. Then there will be linear regression 3, which will have positive as false and intercept as true. Whereas LR4, it will have positive as true but intercept will be false. So if that is the case, we have 4 different linear regression models. Now which is the best model? How can we decide that? So that is known as the hyperparameter tuning. And in this hyperparameter tuning, I will just rub this. We will have LR1 model, LR2, LR3 and LR4. So our training data set, we will split it into 5 parts. First model, we will train on this first 3 folds and test it on fold 1. Then the same one model, we will train it on fold 1, 3, 4 and 5 and test it on fold 2. Then the first LR1 model, we will train it on fold 1, 2, 4 and 5 and test on fold 3. So on for all the 5 splits, we will do the same procedure, and then we will note that, let us say this is split 1. On split 1, the test accuracy or test performance, let us say 98%. Then we have split 2, and let us say the test performance is 97%. If we have split 3, the test performance is 96, and then 95 and 94 on all the 5 splits. So on an average, we have 95% as the performance of model LR1. So we complete this for all the 4 models, and we get the average performance is 95 of model 1, the average is 94, the average is 93 and the average is 92. Out of this, we have the highest average over here. So this will be our final model, and this final model will